Hello, ladies and gentlemen. I hope you're all doing well. We're going to be looking at B3 in this video, B3 from our 2012 Open Contest. And let's take a look at what question B has in store for us. Given the following 4x4 square of points, it's going to be incredibly faint. I'll thicken them up for my low-resolution viewers. But given the 4x4 grid of points, determine the number of ways we can label 10 different points, A, B, C, D, E, F, G, H, I, J, such that the lengths of the 9 segments, A, B, B, C, C, D, D, E, E, F, F, G, G, H, I, J, almost made it through that, are in strictly increasing order. So we want them to increase. Now, this might seem sort of overwhelming at first. There's lots of ways to place 10 points on a grid of 16. And what are they talking about? Lengths and strictly increasing order here. Now, the strictly increasing order, I think, is going to be important because it means the lengths are different. And with such a restricted grid, I have a feeling there's only so many lengths we can do. There might just be 9. There might be a 10th one, in which case then we have to play around with cases. If it were a C part, I would expect there to be 10 or maybe even 11 if it were a C4, but it's a B part, so I'm willing to bet there's only sort of 9 possible ways we can do things. Now, the nice thing here is that we've got this grid. So we could pick points like these 2 points are unit 1 distance away, whereas something like these 2, well, let's change color. These 2 blue points here are 1 by 2 away, so 1 squared plus 2 squared is 5, so this is distance root 5 away. And there's only going to be so many possibilities. So because they're on a nice grid, we use Pythagoras to find lengths between dots. So imagine I had some dots on my grid, and I had two points that I cared about. Use the blue again. I have something like, say, this. The distance between them, let's call it, let's say it's A over B up. This distance here is going to be the distance squared is going to be A squared plus B squared because we've got a nice little grid and therefore a right angle triangle. So D is always going to look like the square root of A squared plus B squared. The question is, what are the A's and B's? Well, they're only ever going to be integers. You know, you go 1 over, you go 2 over, you go 3 over, and 0 up, or 1 up, and so on. So we get just a few possibilities. So make a little grid. So the B's could be 0, 1, 2, or 3. The A's could be 0, 1, 2, or 3. How do I know we can't have a 4? There isn't enough space in the grid. How do you know you can't be less than 0? Well, I mean, if you really want to say things like this is A to the right, then I guess you could have -1 or -2, but it's not really going to affect the possible lengths. And that's all I'm looking at right now. Now, we're not going to worry ourselves with 0, 0, because that would mean that you're talking about the distance from a point to itself. So don't worry about that, because we were told all these points are distinct. There's going to be a lot of, well, not a lot, but there's going to be symmetry in here. I actually don't need to fill out the bottom half of this table, but I will anyway. So this is square root of 1 squared plus 0 squared. This is going to be 1. These distances, they're not that bad to compute. You'll notice there's going to be symmetry along the main diagonal. And then 1 squared plus 1 squared is 2, so this is a distance of root 2. 2 squared plus 2 squared, we're going to get root 8, and root 18 down here. And then 1 and 2, we've already said this one, that's root 5. Same with 2 and 1, root 5. So you can see symmetry now. 3 squared is 9 plus 1 squared. We're going to get a root 10 here. Well, let's get a root 10 here. And actually, I think stylistically, just so it's easy to line these up, because we want strictly increasing order. Gonna write them like this. Even if it's just for a moment. 3 squared is 9, plus 2 squared is 4, so we're going to get root 13 and root 13. So we get 1, 2, 3, 4, 5, 6, 7, 8, exactly 9 unique distances. Root 1 less than root 2, less than root 4, less than root 5, less than root 8, less than root 9, less than root 10, less than root 13, less than root 18. So now I know the order when I go looking at what we want. So I know ij has to be the longest length, so it's going to be a root 18. I know ab is the smallest, so it's just going to be 2 points side by side, that sort of a thing. Oops, pressed the wrong button, I went down a question. Okay, now they want, what was it? How many different ways to arrange these 10 points? Well, label these 10 points, but it's arrange them. Okay. Now, if we're thinking about our grid, there's a lot of ways to place some of these smaller lengths. Okay, you know, you can pick any 2 points and with distance 1 away. So it's not that hard to place AB. But it's going to be kind of tricky to place the largest point, ij, because you have to go 3 over and 3 up. Well, that means I and j are opposite points. Okay? So as soon as I place j, for example, I is forced over here. So we have 4 choices for j. Let's keep a note of that. 4 choices for j. In theory, what we're going to get is, you know, there'll be 4 choices for j. Obviously, there's no choices for I. Once j is picked, I is fixed. But then there might be, you know, 4 choices for h, and then 2 choices for g, and then that might fix f, e, and d, and then there's 3 choices for c, and those sorts of things. We'll multiply them all together. We might also get rather interesting cases, and if that's the case, then we'll have to break it down and look at those. But I think it's probably safest to go longest to smallest in terms of length. So we'll place j and I, and then ih is something we're going to look at. So can we place h relative to this fixed I? Okay, and we're just going to keep track of choices and break it down into cases if we have to. It's just going to be a counting problem. Okay, now when it comes to h has to be root 13 away from I, so it's got to be 3 over, and it's got to be sort of a 3 by 2 away. So we could either do 3 down like this, or 3 over like this, and then down by 2 and over by 2. So we get 2 choices for h. And at this point, there's no reason to suspect one over the other, because it's all symmetric. We just flip our picture. So, but we got to remember 2 choices for h. So right now there's a total of 8 ways to make our current picture. Okay, now g is going to be so root 10, so it's 3 and 1. So once I've picked my h, where could g go? Well, we've got to go 3 away. You can't go 3 in this direction or this direction or this direction, so it's got to be 3 in this direction, and then we get one of these 2. Right? So that's 2 choices for g. Okay. Now, depending on which g we have, I think we're going to run into a little bit of difficulty placing our next one. Yeah, okay, we are just going down in order. So next we're after f, and so we're on root 9. So with root 9, we have to be 0 over and 3 across, sort of. But if our g is down here, and we go 3 across, we've got a problem because j is already there. And if we go 3 up, I is already there. So we run into a problem if g is in that bottom corner. So I don't think there are two choices for G. I think there's just the one choice. Or it might be no choices. Let's just double check. No, I can go 3 across, and no other direction can I go 3 in. So there's just one choice for G, and that also fixes our F. Alright, so that was root 9, now root 8. Let's think about this. So we got to go 2 by 2. Can't go 2 in that direction, can't go 2 in that direction, can go 2 in this direction or this direction, and then the other 2 goes down here. So there's no choices for E either. It's kind of coming together nicely. The answer might just be 8. Alright, so after root 8, it's root 5, right? Yeah, root 5. So that's 1 over 2 up. Can't go 1 over this way and 2 up this way, because that's where G is. Can't go 1 up and 2 like this. Can't go 1 up and 2 like this, or 2 down here, or 1 over and 2 down like this. We can go 1 over and 2 up to here. Can't go 2 over and 1 down or 1 up. This, yeah, looks like D is fixed as well. Okay. Running out of colors here. So D, we're looking at C now. So that's it's got to be 2 away. G's already sort of blocking us, so that fixes C to be down here. And then root 4 goes, should just be down to root 1, right? No, root 2, sorry. So that'll be over by 1, up by 1. So can't go to H, have to go here. So that's where my B is. And so no choices for B either. And then finally, we'll use the purple here. A is 1 away, so we can go here, here, or here. So 3 choices for A. And we didn't have to really break it into cases other than sort of analyzing G and ruling out one of the possibilities. And I was just thinking ahead a little bit. So 3 times 2 times 4, the total number of choices is going to be 24 choices for our points. And there we go. And that's nice. So it's 24 different possibilities. You get to choose your J, you get to choose your H, and you get to choose your A. Everything else is fixed. It's nice, tight, and compact. I like it. It's a good question. I think it could be a harder question if they made the grid ever so slightly larger. And then you'd have more, maybe just 1 or 2 extra lengths, and then you'd have more choices as to what lengths do I include and that sort of a thing. But it's a good question. I like that. Okay, so we're going to have more of the 2012 paper coming up in the next video. Until then, take care. Have a wonderful day.